Hey guys, my name is Frank. This is the Python programming video log, and today I'm going to be covering something really cool, which is my system for doing tile-based collision. So I made a basic little example here where I have a guy who has, I guess you can call it a collision registration point right here in his bottom center. So when he walks over these tiles, he will collide on that bottom center point. Now, a lot of games do this method where they only collide with the bottom center point, and you kind of overlap the tiles a little bit, and it works really well, and it's really simple. I'm going to go over other methods in future tutorials, but I figured this would be the simplest way to do it with just one collision point and just a couple different collision shapes. So before I get into the code, I'm going to explain a little bit about how the system works. Each one of these tiles, rather than doing the same exact collision code, is actually its own collision tile. So if you look over here at the output, I have a tile value of 5. So this tile I'm standing on is a 5. This one's also a 5. The 5 tile only does collision on the top, and it only processes that there is a collision if the character is entering into that tile from the top. So theoretically, if I go to my map, and I'm actually going to do this right here, I'm going to come down to my map, and I'm going to put a 5 tile right above where my character is standing, right there. And I'm going to show you that it doesn't do collision on the bottom because it only detects collision on the top. So this is great if you're making a platforming game because you can jump up through the bottom and onto the top. So you have that option. The only downside to this is that you have to really kind of focus on your level layouts, because all the tiles do a different type of collision. The upside is that this type of collision detection is super modular, and it's really great and smooth. Like, it works really well. Like, I'm just hitting all the sides of these shapes, and collision is happening the way I expect it to. Also, since I'm only doing collision per side of shape, like, these are composite collision tests in each one of these tiles. For example, the one that I just tested, the 5 tile, only does collision on the top. This one here, which tile is this? If I jump on, it'll tell me. Tile 4 does collision on the left, top, and right side only. If I come over here and I jump up, you can briefly see a 3 there in the tile value. This is a type 3 tile, and it only does collision on the right side. So if I come into my map and I replace this 4 tile with another 3 tile, I can't walk through the right side, but I can jump through the top, and I can walk through the left side. And I can go right through, and it doesn't look glitchy or messed up or anything, and I can't walk back through that right side. So hopefully you understand what I'm saying here. It's really not as complicated as it sounds. I think it's actually more simplistic than traditional tile-based approaches, and I'm sure that this is out there somewhere else. I'm sure I'm not the only guy that came up with this, although it's nice to think that, but I'm sure that's not the case. So anyway, I'm going to come over here into my code, and I'm going to explain basically just my game object. You've already seen how to do, in previous tutorials that I've made, how to do the display and how to handle controller input and stuff like that. So, and you've actually already seen in other tutorials a lot about like the player and the world object and the game loop and how to do all that stuff, but there are a few tiny changes here. So for instance, the player, one change that's new inside the player is I keep track of the old X and Y position. And the reason that I do this is because when I'm doing my collision checks on my tile, well, to give you a better understanding, when I'm walking through the left side of this tile and coming out the right side, what's happening, the reason I can walk through and it doesn't mess me up on the right side when I'm going through that is because it only detects collision on this tile if I'm moving to the left. Because you can't enter a tile through the right unless you're moving towards it from the left. So I don't even check to see if a character can move into this tile from any other direction because this tile doesn't care. The specific use case of this tile is inside of a wall where you would never ever have access to it from any other side but the side that's exposed to the inside of the map. So you have to be careful with this approach because if you have random tiles just strewn about, it could look like there's a glitch in your game when really the code is doing exactly what it's supposed to do. You just have to be really attentive to your level layout and make sure everything is in the right place. But when it is, it works perfectly. So the reason I have to keep track of the old X and the old Y is because to determine if a player is moving into a shape, I have to test, was the old position outside of the shape? And is the new position inside of the shape? And is that vector pointing in the direction of the collision side of the tile? I feel like I'm not explaining this the best, as I usually do. I feel like my explanations are lacking, and that's probably because I'm just doing this on the fly. This is just an improvised explanation of the code that I wrote. And I'm also excited about it because I haven't programmed any tile-based stuff in a while, and I really love doing this. So my word of advice to you would be to go download this code from my GitHub page and use it for yourself. Also, check out the interactive example. There will be a link to that as well. You'll be able to actually have access to this example right here and use it. So I'm going to explain the code now. I'm just going to go over the collision code and stuff that makes this work, and I'm not going to rave anymore about this method of doing collision. I'm just going to go over the code. First, I'm going to change this back to a 4. Which I think this was. Also, the colors are just generated. They just skew the color a little bit. It's a hex color, and I just add, the value of the tile to that hex color, depending on which tile is being drawn. So that's how these are different colors. Actually, I'll go up there and show you that inside of my display function. What's happening here is when I draw each tile, basically I just splice in the value of the tile, which is going to be 1 through 5. And I just put that into the color itself. So that's why these are all slightly different colors here. Just figured I'd explain that if you were like, why are those tiles different colors? So anyway, keep a note that I'm keeping track of the old X and Y position of my character to use in determining if he was inside or outside of a shape and what the vector of direction is that he's entering that shape on. That's pretty important. It's also really useful for other game physics, so you might as well just get used to keeping track of the old X and Y coordinates of your objects. Here is the world object, and that just keeps track of stuff about my map. So for example, here's my one-dimensional tile map array with my collision shape values in there. I have 8 columns and 5 rows in my map. I'm going to come down here. This is the cool part. And if you want a better explanation of this stuff, like I said, go get the source code. And I have all these lengthy comments in there trying to give a good example of it. But here's my auditory example of it. This is the collision object. And inside of the collision object, I have what I like to call routing functions. So basically how this works is each routing function represents a tile. So 1 here, the function labeled with 1, is referencing a tile with a value of 1. And I think that would be this tile up here, 1. So if I want to check out the routing function for 5, I can come down here in my code to the function label 5. And as you can see, inside of this function, it's going to call the top collision method. And this tile here only has collision on the top, as I showed you guys before. So if I go to 4, that has collision on the left, the top, and the right side. And as you can see, the tile value of the tile I'm standing on is 4. So if I check out the routing function for a tile value of 4 in my map, basically what it does is it checks to see if a top collision, a left collision, or a right collision is occurring. And inside of these individual functions, it will detect and resolve that collision. I'll get back to the routing functions and how they're used after I explain these internal functions. So down here, also in my collision object, are my, I guess you can call them narrow phase collision detection and response functions. The broad phase collision detection is just determining, is my player inside of a collision tile space? So is my player inside of a tile space that is not equal to 0? Because all tiles with a value of 0 I can walk through or move through freely, and any tile that's not a 0 is going to be a collision tile. So once I detect that my player is inside of a tile and it's hard to tell, but the bottom of this player is basically inside of this tile with a value of 5. Once it detects that he's inside that tile, it's going to go over here, and the routing function is going to call these specific functions for each tile. So say left collision is the one I'm going to use here. Actually, you know what? I should do top collision, even though this has all these comments on it. I'm not going to read the comments or anything like that. I'm going to go down to the top collision function because I'm standing on these tiles, and 5 tiles do top collision. So inside of my routing function for the tile value of 5, I call this top collision function. So if I go up here to my routing function for tile 5, which is up a little ways, gotta scroll. Inside of my routing function, basically what's happening is I'm detecting that I'm inside of this tile space. The bottom of my player is inside of this tile space. It has a value of 5. So I call the routing function labeled 5. And inside of that function, I call the top collision function. So that's what's happening there. So when I go down to the top collision function, basically what it's going to do, excuse me, is a little more broad phase collision detection here. It's going to say you can only enter into this tile from the top if your level is laid out correctly. So unless you're falling down, unless your character is moving down or it has a y velocity that's greater than 0, you're not going to be able to collide with this tile. So if I was moving up through this tile, like I showed you when I had that tile over here, I wouldn't even bother with doing collision detection because that's not what this tile is made for. This tile is made specifically to be a floor tile. So once I determine that I'm actually moving in the right direction to collide with this type of tile, then I go on to the specifics. Now this takes 2 arguments. It takes the object itself, which is just my yellow rectangle here, my player object, and it takes the row that I'm colliding with. So I know when I'm detecting which tile I'm in, what row and column that tile is in. So right now the row or the tile Y value is 4. And if I count here, I've got 1, 2, 3, 4, 5 tile spaces. But since I start at index 0, it would be 0, 1, 2, 3, 4. So I know I'm inside of row 4. So I can actually calculate based on the row and multiplying by the tile size the exact Y location of the top of this tile. So if I say the row is 4 and I multiply 4 by my tile size, which is 40, 4 times 40 is 160. So if my players, well, actually, the top of this tile would just be at 160. Then in this if statement, I test to see if my object's current Y position plus the height, which is going to give me that bottom reference point, that bottom collision registration point inside my character object. I'm going to test to see if that is below the top of this tile, which is 160. So since we're having collision here, we know that it is. And I'm also going to have to check to see if the last position was above the top of my tile. This ensures that if I'm falling down, the old position is going to be outside of my tile and the new position is going to be inside of my tile, and I know that I'm actually entering into the tile. So then once I know that I've entered into the 5 tile here from the top, I know that I can do my collision response. So it's really, really simple. The collision detection is just testing to see if I'm entering into the top of this tile, and then the response is simply setting the position to the top of tile, the position of my object, just pushing it out to the top of my tile. The reason this 0.001 is here is just to eliminate rounding errors. So the reason for that is because the way I calculate what row my player character in or what the Y tile is just by dividing the player's Y position by the tile size, which is 40. So if I push this player back out to the exact top of this tile, it's going to still be inside of the tile. So I have to push it just a little bit more out. So 0.001 pixels more out of that tile in order to put it above that tile space. So that's all that's there for. And you don't have to worry about that on the right side or the bottom side. Only the top and the left you have to worry about that extra little push, just because the way I calculate which space my player character is in. I could probably also do something. I'm going to see if how far I can push this. If I make it a really tiny number, it's totally unnecessary, but let's see what happens. All right, nothing happens. It works the same, but you really don't need a number that small. That's kind of ridiculous. You could go with 0.01, and that's probably fine. You're not going to see a gap or anything because of the way things are drawn. It's not that precise. If we ever get a device that has support for that kind of pixel density, that would be crazy. So anyway, this is just a collision detection function and response function for one of the sides. If you look at what's going on here, it's basically the same collision response code for if I run into a wall. So if I come over here and I run into a wall, it's the same exact code to run into a wall, except I don't have to test if I'm moving into the wall. It's really, really simple. It's not what you would come to think of from the complex tile-based collision detection methods that you see on the internet. Really, mostly what this is just looking up what tile space you're in, and then checking to see if you're entering into the specific side, and then resolving collision very simply. But you can put whatever you want inside of this stuff. You could have a function called left-facing slope, and you could put collision code in there for that, or you could have a function called arbitrary curve, and you could have collision code in there for that too. And the same code that works for an arbitrary curve would work inside of a tile collision function. So now, actually, before I go down, I'm going to just say that the top collision method, you can basically take the same approach that was used in the top collision method and use it for all your other collision methods. You just kind of swap out directions, and instead of using y coordinates, you would use x coordinates and stuff like that. But basically, it's the same structure and the same basic concept. So now I'm going to go down into my game loop. I do some controller stuff. I get input from the controller, and I add to the player's velocity, test to see if I'm jumping or not. When I press up, I'm going to jump. I add one to the velocity for gravity. Here, I'm storing the player's old X position. So at the start of each game loop, I'm going to take that old current position and store it in my old player position. Then I'm going to set the new position before I draw, and I'm going to do that by adding the velocity to that position. Here I'm doing basic collision detection and response with the sides of the screen. So here, if I'm all the way past the left side of the screen, you just, you set the player so he's not colliding with that anymore. And basically I have a function for each side of the screen, the top, the left, the right, and the bottom. That's simple stuff. You've seen it before. I've gone over it a bunch of times in other tutorials. Down here is the cool stuff. So I went over this pretty well in the last tutorial, how to calculate what space your character is standing over and how to use that information. But basically, I'll just go over it really quick. What's happening here is I'm calculating the X and Y tile position of my character. If you look up here, you can see those values. All I do is I take the X and Y location of that bottom registration point on my character, and I divide it by the tile size, which is 40. All the tiles are 40 pixels wide and 40 pixels high. And that will give me, with these two functions, my X and Y tile position, or row and column tile position, or I guess X would correspond to column and Y would correspond to row. But this will basically calculate which grid space or tile space my player is inside the map. Then I calculate what value I'm standing over inside the tile map. So basically, this would be my map index. So if I go, I wish I can get to the top because it's easier to do that. But basically, if I go right here, I'm going to be at index 33. So if I counted each tile like 0, 1, 2, 3, 4, 5, 6, 7, 8, and I went all the way across and down, this would be position 33. And the value at position 33 in the map is a 5. So then I know that I got to do a collision with a 5 tile, so I use that 5 routing function. So all I'm doing here is I'm getting the X and Y tile position and the index at that position in the map. Then I'm going to do some output so you can see this stuff right here. Then I'm going to come down here and I just basically say if the value in the map that I'm standing over is a 0, so if I come over here and I jump, you're going to see that tile value in the output go to 0. If it's a 0, it's a walkable tile and I don't have to do anything, so I'm just going to exit this if statement. If it's anything but a 0, so a value of 1 through 5, I'm going to have to do some collision. So I basically just call the collision routing function. I just say collision, and it's cool when you label something with a number like I did in the collision object. So if I go back up here, in JavaScript, you can do this cool thing where inside of a object, you can label different values with a number just like this, and then you can reference that in an array really simply. So if I come back down here, hopefully that gives you a slightly better understanding of how I'm accessing these routing functions. So I basically just pass the value that I'm standing on, so say a 5, into my collision routing function, or into my collision object. It gets the routing function at that index value, and I call the function. Really simple. I pass it the player object, and I pass it the row and column position that he's standing in. And then it does all that stuff that I explained before, and it detects that narrow phase collision, and it handles the response if there is in fact a collision. So then the only other thing I have to do, that's basically it. That is collision detection. The only other thing is that may only be collision on one axis. So say, actually before I do this, I'm just going to show you what happens here, because I basically have to do the same code twice. So if I come here and I comment this out, just like that, and I refresh my example, do you see that now I'm moving right through that tile there? Before that wasn't happening. Now the reason this is happening is because my collision code is only running once, and I have 2 different axes that have the potential to have collision tiles on them. I'm moving in 2 different directions. I'm moving down on the y-axis and left and right on the x-axis at the same time. So I have to test for tiles on the x and y-axis. Now, with this method, the order, x first or y first checking, doesn't matter. All that does matter is I check twice. And that will change depending on how many registration points for collision I have on my player object. So for instance, right now in this example, what's happening here is I'm checking to see if I'm colliding with a tile. My 1 registration point is colliding with the tile, and it's this 5 tile right here. So when I move my guy, he's detecting collision on that bottom tile because on every frame, gravity is pulling him down into it. And he's detecting collision, and he's being moved out by this stuff right here. And after that, the game loop just exits because that's it. It's the end of the loop. So he never even tests collision with another tile space. So he just moves right through this tile that before was stopping him. So how do I resolve this issue? I simply run the same code twice and update my player's row and column, or column and row, or that X tile and Y tile value. Because after I resolve collision, those are going to change. He used to be in this tile space. Now he's in this tile space after collision occurs on this 5 tile. So when I come back down here and run my collision code again, in this case, it's going to do another check on the x-axis for this tile. And now I have collision with tiles on both the y and the x-axis. And like I said, it doesn't really matter which axis it checks for first. It could be anything with these random tiles, the way they check for collision. But the important thing is that you're only ever going to be moving in up to 2 directions at once. So I can move up and left, I can move down and right. I can't move right and left, and I can't move up and down at the same time. I can only move in one of those directions or not at all on a single axis. So I just have to check for collision twice if I have 1 registration point. And that's it. Hopefully I covered everything. I think I got everything. The only other thing is that I do my friction after my collision functions, and that's really not important. It would be important if I were setting the player's velocity to 0, which doesn't make any sense. But I just don't like using this because it's inside. If I come back up to my collision code here and show you this, if I can make it up back to the top, I'm using my velocity inside of my collision functions to determine which way my player is moving. And if I alter that velocity and it somehow gets set to 0 before I do my collision, my player may have moved actually. So a better way to do this would be to calculate velocity or vector of movement by subtracting the player's current position from his old position, or subtracting the old position from the current position. One of those, but that will give you a more reliable means of determining if the player is moving or has moved in a certain direction from one frame to the next. So I don't really care for using velocity. That was an afterthought before I made this video, so I just wanted to explain that real quick. And that's it. If I go down past there, that's the end of the game loop. The last thing I do in the loop is render everything to the screen and request that the loop execute again on the next available draw frame of the browser window. And then this is it. That's the end of my JavaScript file. And most of this, it's 388 lines, but most of it is actually white space and comments. So I don't know what you could condense all this down to, but basically you have a fully functional and pretty nice tile example here that you could easily add new shapes to in, 388 lines, and definitely less than that. So hope you guys learned something. Definitely stay tuned for the next video. I'm going to be going over different kinds of shapes. So you're going to see half tiles, half height tiles, half width tiles, slope tiles. I've never done this before, but I would love to actually implement a curve tile. So just an arbitrary curved tile, maybe for like a mound on the ground or just something cool. I don't know if you ever played Endgame, but it's a game where you're a ninja and you got to jump on the walls, and it's a tile-based game that uses arbitrary collision shapes, kind of like what I'm doing here. So I want to go over all that for you guys, and hopefully you guys use the code and make some really cool games with it. But anyway, stay tuned, like the video, subscribe to the channel, and I'll see you guys next time.